Okay, chalo. Okay, no? Sorry. Chalo. So what was the question, beta? Efficiency was 50% and temperature of the sink was 500 Kelvin. Now, if the efficiency is being increased to 60%, what will be the temperature of the sink? Temperature of the source is being kept to be the same. So I'm using the sink formula, neta is equals to 1 minus T2 by T1. Efficiency is 50%, so 50 by 100 is equals to 1 minus 500 by T1. So it is 1 by 2 is equals to 1 minus 500 by T1. 1 minus 1 by 2 is minus 1 by 2, minus minus gets cancelled. 1 by 2 is equals to 500. So T1 will be equal to 500 into 2, that will be equal to 1000 Kelvin. Now when efficiency is being changed, so I'll write here right now, neta dash will be equal to 1 minus of your, I need theta dash. This will be equal to temperature of the sink is nothing but of your T1 I got, that is nothing but of your 1000 Kelvin. Isn't it? Now efficiency is how much for me? 60% he told. So it is 60 divided by your 100 is equals to 1 minus of T2 dash divided by your 1000. So this one and this one will get cancelled. So this will become how much for me, beta? This will be 2 3s are 6, 2 5s are 10. So this is 3 by 5 is equals to 1 minus of T2 dash divided by your 1000 Kelvin. So if I simplify it, I'll be getting from this one, T2 dash will be equal to your 400 Kelvin. Is that clear? This is the way how we do the such type of questions. Clear? Sure. Next, one more question. Question number 10, you see, beta. Question number 10 says that we got 2 moles of an ideal gas. So number of moles is equals to your 2 of monoatomic gas. Gas is right now for me your monoatomic gas. I'll read the question. 2 moles of an ideal gas, monoatomic in nature, occupies a volume V at 27 degrees centigrade. So it occupies a volume V. It occupies a volume V at a temperature of your 27 degrees centigrade. Now the gas is expanded adiabatically. It is expanded adiabatically to a volume. That means V dash will be equal to your 8 times of your V adiabatically. It is increased adiabatically. So that final temperature of the gas is how much? So T2 will be equal to how much? This will be equal to your T1. So as it is a monoatomic gas and adiabatic process, the relation between temperature and volume, we know it better. What is that relation better? TV to the power of gamma minus 1 is equals to your constant. Isn't it? So I can write here right now from this one. Okay, so T2 divided by T1, T2 divided by T1 will be equal to your V1 divided by V2 to the power of your gamma minus of your 1. So V1 is nothing but V, V2 will be equal to your 8V. For monoatomic mass, gamma will be equal to how much beta? 5 by 3 minus 1. What type of a gas it is right now beta? Ideal gas and monoatomic in nature. Clear? Is it clear? For monoatomic gas, what is the value of your gamma beta? Yesterday I told you. For monoatomic gas, if I am remembering the relation, see this is the value of your gamma. I have written in the box somewhere for you here. Where is that I have written? Yeah. Gamma value for the monoatomic gas. How do you write the value of gamma? For gamma atomic monoatomic gas, the degrees of freedom is nothing but of your 3. And how do you calculate the value of your gamma beta? I told you the formula for your gamma. See, yesterday I told you. Gamma value is equals to 1 by 1 plus 2 by 3. 1 plus 2 by 3 will become for me 5 by 3. I hope you got it. Sure. So that will be equal to your 5 by 3. That is the way how do I got this one. This V and this V will get cancelled right now for that one. So this will be equal to your initial temperature is 27 degrees centigrade. So convert into Kelvin. So it is T2 divided by 27 plus 273. That will become for me 300 Kelvin. That is equals to your, this is 1 by 8. Isn't it? So this one is your 1 by 8 to the power of your, how much I'm getting beta? 5 by 3 minus 1 is how much for me? 2 by 3. Okay. So this will become how much for me? This will become for me 1 by 4. So T2 will become for me 300 divided by 4. So that will be equal to your 75 Kelvin. Clear? Is it clear? Sure. Now I'll write here onwards. The remaining questions you try to do it better so that it will be more better for you to do. Then only you can able to understand the remaining questions you can try to do and clarify the doubts related to that one. Okay. Is that clear? Sure. Next question. Say for example, a gas is suddenly compressed. A gas is suddenly compressed to 1/4 of its original volume. 1/4 of its original volume. Okay. What is the rise? What is the rise in temperature? Temperature. The original volume. What is the rise in temperature? The original volume is, say for example, Fermi or V part of relation. Original volume is V. First of all, what is the rise in temperature? What is rise in temperature? What is the rise in temperature? I've just missed one line here right now. Yeah. What is the rise in temperature? The original volume. The original volume. First of all, what is the rise in temperature? The original temperature being 27 degrees centigrade and gamma value is given as 1.5. I'll give the options: 300 degrees centigrade, second one is your 350 degrees centigrade, third one is your 400 degrees centigrade, and fourth one is your 450 degrees centigrade. Okay, so gas is suddenly compressed to 1/4 of its original volume. 1/4 of its original volume. What is the rise in temperature? So original volume is, say for example, V, and final volume is, say for example, how much? 1/4 of the gas is suddenly compressed to 1/4 of its original volume. So like say if original volume is V, initial is V, and V final will become for me 1/4. That means V/4, isn't it? What is the rise in temperature being 27 degrees centigrade? That means initial temperature being is how much for me, beta? What is the rise in temperature? The original temperature being 27 degrees and gamma value is given for me. That means initial temperature will be equal to your 27 plus of your 273. That means that will be equal to 300 Kelvin. So temperature, right? That means T final will be equal to how much? Or T2 will be equal to how much? Again, temperature and volume relation beta. So it is a TV to the power of gamma minus 1 is equals to constant. So it is a T1 V1 to the power of gamma minus 1 is equals to T2 V2 to the power of gamma minus 1. Isn't it? T1 is given how much for me? 300 into V1 is nothing but V to the power of gamma. Gamma value is given as 1.5 minus 1. That is equals to T2 we need to calculate. V2 is nothing but of your V/4 to the power of your 1.5 minus of your 1. Clear? So from this one, I can cancel this V and V beta. This V and this V will get cancelled. So this one will be your 300 here, and this one will be, this will become how much for me beta? V to the power of your, I'll write here, I'll not cancel, V to the power of 1/2. That is equals to your T2, and this one will become for me 1/, so V/4 to the power of, this one is also your 1/2. This way and this way I can cancel here right now beta. To the power of 1/2 to the power of 1/2 also will get cancelled. So this will become for me how much better? So this is a 300 is equals to T2 1/4 to the power of 1/2, isn't it? So this will become for me how much? That will become for me T2 into your 1/2. That means T2 will become for me 300 into 2. That means this will become for me 600 Kelvin. So T final will be equal to how much better? That means T2 will be equal to your 600 minus of 273. That will be equal to 327 degrees centigrade. So it is your 327 degrees centigrade. So 327, which is nearby answer, I can write 300. Clear, beta? Is that clear? Okay. Sure. This question. Very important question, beta. See here, beta. During an experiment, an ideal gas is found to obey an additional law. An additional law, Vp square is equals to your constant. Okay, then the gas is initially at a temperature capital T and volume is say for example V. Okay, so what will be the temperature? What will be the temperature of the gas? Temperature of the gas when it expands to a volume of 2V. Very good question. Semantic questions compulsory, you should get an idea how to do them basically. See, I'll give the options. First option is given as root 3 times of t. Second option is given as of your under root of your 1 by 2 into t. Third option is given as of your root 2 times of your t. And fourth option is root 3 times of your capital T. Okay, so try to see. What he has given me for the process beta, Vp square is equals to some constant. So we can use an ideal gas equation. PV is equals to NR into T. So from this one, P is equals to how much beta? NR into T divided by V. Substitute that value here right now. In the place of P, it is N into R into T divided by V into your whole square is equals to some constant K. Okay, so now this will become for me, N is a constant, R is a constant, and here we need to write the relation between temperature and volume. So I'll be writing this one as V into, this will become for me T square divided by V square is equals to total constant I'm taking right now, like it's a C. That means I can say this is V and this square will get cancelled right now. So V square is directly proportional to, right now tell me, sorry, T square. So T square will be proportional to. So it is a T square divided by V is equals to some constant that is nothing but C. That means T square will be equal to V into C. So that means I can write V is equals to, sorry, this is T. So this one is right now for me your T. This is your T square. So I can write T is equals to some constant. So constant value, I'm taking it as of your C value. I'm taking it as of your 1. So I can write from here, T is equals to root times of your V. Okay. So that means it will become for me root T. Okay. Is that clear? That means it is root 2 times of your T part definition. Is that clear? T square is directly proportional to your root of your V. Clear, beta? Is it clear? So what will be the temperature is asking. So temperature is equals to root 2 times V value, whatever here taking the V value, you can substitute and simplify the relation for that. Clear? Is that clear for everyone? Sure. One more question. Say for example, I have got a cyclic process. A cyclic process A, B, C, A as shown in figure. As shown in figure. Find efficiency. Find efficiency is equal to how much? So the diagram is something like this. Okay. So in this one, what I've done is I'm giving some energy here right now for this one. So for example, 500 joules. I'm giving here right now certain input that is equals to 50 joules. And from this one, I'm taking an output that is equals to 200 joules. This one is A, this one is B, and this one is C. There is a flow of your heat like this. Okay, so now Q positive will be equal to how much beta? Whichever is being given, that is 500 plus 50, that is given to the system. So that will be equal to 550 joules. Q negative, that means which is given by the system, that will be equal to how much beta? 200 joules. So efficiency will be equal to how much beta? It is 1 minus of your Q given divided by Q taken. So that will be equal to your. So I can write here efficiency neta will be equal to 1 minus given is nothing but 200, taken is nothing but equal to 550. This one will get cancelled. So this one is nothing but 20 divided by 55. That means this will become 4 and this will become for me 1. So efficiency will be equal to 1 minus of 4 by 11. So that means that will become for me how much? 11 minus 4, that is 7. 7 by 11. Clear? Is it clear? Sure. One more question in that one. Right. If I give in terms of a graph like this, find efficiency. Find efficiency for given process. See, I have given you the process right now here. This is your graph which has been given for us. Okay. And this one is your pressure and here is your volume. And in this one, we are having the coordinates like this. Okay. So going from here, then here, then here, and then here. Okay. This is a process A. This is your B. This is your C. And this is your D. If I have given you the coordinates right now for this one, so here right now one coordinate, and here it is one coordinate, and here it is one coordinate. Here the pressure is 2 times of P naught, and here it is nothing but P naught. Here it is volume V naught. Here it is your 2V naught part deflation. And temperature here is 4 T naught, and temperature here is 2 times of your T naught. That extra data is also given. This is a temperature T naught, and here it is given a temperature of your T naught. And the gas, whatever we are taking, is nothing but of your monoatomic gas. We are taking your monoatomic gas. Can anyone try it, Veda? As it is a monoatomic gas right now, efficiency will be equal to your right now. Whatever the energy we are giving to the system right now, so energy will be equal to your whatever is given and whatever is taken. So let me try to calculate first the Q of your process A to B. That will be equal to your N into Cp into delta T. From A to B, pressure is remaining constant. So how many number of moles? N number of moles. And for monoatomic gas, Cp will be equal to how much better? 5R divided by 2. Temperature difference will be 4T minus 2T. That will be equal to 2 times of T naught. This 2 and this 2 will get cancelled. So that will be equal to 5NR into your T naught. That means that will become for me 5 into P naught into V naught. The same way, Q from your B to C. From B to C, volume is remaining constant. So it is N into your CV into your delta T. Monoatomic gas for this one, CV will be equal to 3R by 2 into final is nothing but 2T and initial is nothing but 4T naught. So they will be getting 2T naught minus 4T naught is nothing but minus of your 2 times of your T naught. This 2 and this 2 will get cancelled. So I'll be getting the answer in terms of negative. So that will be equal to minus of 3NR into your T naught. That means that will become for me minus of your 3 into P naught into V naught. This is your Q from B to C. Okay, so in the same way, if I'm talking about your from Q from your C to D, see the diagram, C to Z, again pressure is remaining constant, so it is N into Cp into delta T. Number of moles is N, Cp will be equal to 5R divided by 2, temperature difference will be T naught minus 2T naught, so this will be again will be getting in terms of negative, that is minus T naught, so I'll be writing this one as 5 by 2 into your P naught into V naught with negative sign, isn't it? In the same way, if I'm writing right now energy right now from your energy and D to your A. So if I'm writing from D to A, can you tell me what is D to A? So D to A, what is remaining constant? Volume. So it means N into CV into your delta T. Number of moles is N into CV is equals to 3R by 2 into temperature will be equal to T naught. 2T naught minus T naught. So that will become for me 3 by 2 times of your P naught into V naught. Now tell me what all Q positives are there. So Q positive will be equal to your 5 plus of your 3 by 2. Into your P naught into V naught. That will be equal to how much better? 5 plus 3 by 2, 10 plus 3, 13. So that will be equal to 13 by 2 times of your P naught into V naught. And what is all Q negative? Q negative will be equal to how much better? So this will be equal to your 3 plus that is 5. That means it will be equal to how much? Can you tell me? Minus if I'm taking out right now for this one. So Q negative will be equal to your 3 plus of your 5 by 2 into your P naught into V naught. 3 2 is 6, 6 plus 5, that will be 11. So it is 11 by 2 into your P naught into V naught. Now if he's asking the efficiency, how do you write the efficiency? Better neta is equals to 1 minus of your Q negative divided by Q positive. Antena. So that will be equal to 1 minus, this is your 11 by 2 times of your P naught V naught divided by 13 by 2 times of your P naught into V naught. This one and this one will get cancelled. So if I'm writing this one, how much I'm getting right now? See, this is your 1 minus of your 11 by 2 into your 13 into this one is nothing but 2. This 2 and this 2 will get cancelled. So it is 1 minus of, this one is your 1 minus of 11 by 13. LCM if I'm taking, that will be equal to 13. So 13 minus 11, that will be equal to 2. So it is 2 by 13. So if I'm taking the efficiency of this one in terms of percentage, that will become for me 200 divided by 13%. So that will be the efficiency. Good question, but little bit of your practice can help you out to do such type of equations comfortably. Is that clear? Is that clear? ఇలాంటి క్వశ్చన్స్ ఒకటైనా కంపల్సరీ ప్రాక్టీస్ చేయాలని అందుకోసం I have given right now here. So be specific and try to do that questions related to that one. Any doubt, beta? Any doubt? Okay, na? Sure. So that was about your thermodynamics part affiliation. And if you have got some of the questions related to that thermodynamics part last time, whichever I have given you, you can practice that questions also better. I hope you are having the assignments related to the thermodynamics part affiliation. If you can try to take and try to solve the numericals of that part. Okay, now? Clear, beta? I'm being little. Okay, fine. So anyhow, even you got a mic problem, I don't know how far it is going to work out. Are you able to follow? Is it fine? The assignments also which I sent you thermodynamics, please try to complete the assignments also better. They are really very good assignments. Yes, sir. Okay, sir. Shall we complete your kinematic or kinetic theory of gases later? Sure. KTG. Kinetic theory of your gases. So I'm not going to tell you the postulates and that all. I hope you remember that one. What are the postulates of a kinetic energy? Which are very, very important for you to remember. Molecules of the size are almost all like negligible. Molecules are assumed to be on hard spheres and all the collisions are elastic in that one. and there will be no interaction energy among the molecules. So the total kinetic energy plus potential energy is conserved. Collision time is almost all negligible, and effect of gravity on the molecules are also neglected. Real gases obeys the ideal gas, that is PV is equals to 8 nRT at a high temperature and as well as of your low temperature. This is the point to be noted right now. If I write the first point to be noted in this one, all real gases obeys ideal gas law. What is the ideal gas law? PV is equals to nRT. At what temperature? At very high temperature, T, and very low pressure P. This point to be noted. Okay. Now next one again, because it is already you have done chemistry part affiliation. So at STP, if I'm talking about at standard temperature and pressure. At standard temperature and pressure part affiliation, pressure is always taken as, have you remember that one better? Pressure is taken as of your P is equals to your 1 atmosphere. That is temperature is being taken out what better? Temperature is given as of your 273 Kelvin. And PV is equals to nRT. From the relation PV is equals to nRT, volume will be equal to how much? Volume is equals to N into R into T divided by your P. Number of moles I'm taking 1. R value is nothing but 8.314 into temperature is nothing but 273 divided by pressure is equals to 1 atmosphere. 1 atmosphere is 1.013 into 10 to the power of 5. If I simplify this one, the volume which I'm getting is 22.4 liters. Or else actual value, if I write that one, that will be getting as of your this will be your 2.24 into 10 to the power of minus 2 meter cube. If I'm writing in terms of liter, that will be 22.4 liters. So this is the volume. Clear? This is a very important point to be remembered better. Volume will be equal to 22.4 liters. Pressure will be 1 atmosphere and temperature will be equal to your write properly. Temperature will be equal to 273 Kelvin. At what condition? At STP condition. Clear? The next one. What are the laws better in this one? I hope you remember that one. So the first law is known as of your Boyle's law. Okay, Boyle's law. In Boyle's law, what remains constant, beta? Temperature remains constant. So P is inversely proportional to your volume. P is inversely proportional to your volume, keeping the volume constant. That means I can write P1 V1 will be equal to your P2 into V2. The graph drawn between the pressure and volume will be a rectangular hyperbola like this, because it is like y is equals to 1 by x. P is equals to your 1 by V part relation. Now volume I can write in terms of area beta. So it is a P1. Volume is equals to area A1 into your L1 is equals to your P2 into A2 into your L2. If area of cross section is same, if A1 is equals to your A2, I can write a P1 into your L1 will be equal to your P2 into your L2. P2 into your L2. This is one form I can write. In terms of your spherical bodies, if I'm writing, I can even write like this. So this one is nothing but a P1 into volume will be equal to 4 by 3 pi into your R1 cube is equals to your P2 into your 4 by 3 pi into your R2 cube. 4 by 3 will get cancelled. So it is a P1 into your R1 cube is equals to your P2 into your R2 cube. Isn't it? So this is also one of the important relation you need to remember in terms of your radius and in terms of your length. So this is your in terms of your radius and this one is in terms of your length. And this is your general formula what we need to remember in that one. Is that clear? Boyle's law says that the pressure of a fixed volume or fixed amount of a gas varies inversely proportional to the volume. That means if the temperature is maintained for me constant. The next point is nothing but of your next law, Charles law. I hope you remember the Charles law beta. So Charles law is nothing but what beta? Pressure is remaining constant. I'm taking here right now P is equals to constant. So Charles law says that the pressure remains constant provided the volume of a fixed amount of a gas varies directly to the absolute temperature. That means volume is here directly proportional to your temperature. So I can write from this one V1 by your T1 will be equal to your V2 by your T2. So the graph will be a straight line passing from an origin like this. So if I'm drawing the graph between the volume versus your temperature taken in terms of a Kelvin, that will be a straight line passing like this. Okay, if I'm taking in terms of your Kelvin, so the graph will be something like this. This is a Kelvin, and if I'm taking in terms of your temperature degree centigrade, so this is your temperature, this is your volume, and the graph will be something like this. And this temperature will be equal to minus 273 point of your 14 degrees centigrade or 15 degrees centigrade particulation. Clear? So it is one of the important relation you need to remember about your Charles law. The next one is partial law of pressure, you know it. So pressure exerted by any mixture of non-reacting gases is always equal to sum of their partial pressures. Dalton's laws of your partial pressure particulation. Now tell me the different forms of an ideal gas. So if I'm writing about right now, fifth one is about your ideal gas. About your ideal gas. So what is ideal gas equation beta? PV will be equal to NR into your capital T. Okay. So what is your N here right now beta? Small n is nothing but equal to your number of your moles. Number of your moles. So if I'm writing this one in different forms beta. Let's see the first form. PV will be equal to number of moles can be written in terms of your N by Avogadro number into R into T. Capital N is nothing but total number of molecules of gas. Ne is your Avogadro number beta. Avogadro number value already you know 6.023 into 10 to the power of 23. And if I'm writing in this value, this will be also written as of your P into V will be equal to your N into K into T. Because K is your Boltzmann's constant and the value of your K is nothing but of your universal gas constant by your Avogadro number is known as of your gas Boltzmann's constant. And the value of this one is approximately, the value of your K is approximately 1.38 into 10 to the power of minus 23. Unit is joule per your Kelvin. Is that clear? PV is equals to your N into KT. K is equals to your R by your N into your A. And PV is equals to your N by your N into your A. So I'll write the values there right now. What do you mean by capital N beta? Capital N is nothing but of your number of your molecules. Number of your molecules of your gas, total number of molecules of your gas. And what is an Na? Na is nothing but Avogadro number. Avogadro number, and the value of that one is how much better? 6.023 into 10 to the power of 23. And if I'm writing in terms of your mass, so I can write that one in terms of your mass also better. So if I'm writing that one in terms of your mass, I'll write here. So PV is also equal to N is equals to mass by your molecular weight into R into capital T. Or else I can write here P is equals to your M by your V into your R into T divided by capital M. So I can write here P is equals to mass by volume is nothing but density R into T divided by your capital M. So these are the three different forms in which I can write the pressure. And this is in terms of molecular weight. And in this one is the general formula. N is nothing but of your number of moles. Now what is here N beta? N is nothing but of your number of moles. Sorry. N is equals to your number of your moles in this one. Capital M is your molecular. What is a molecular weight or mass? What is another thing? Rho. Rho is nothing but equal to your density. So density of your gas, whatever you are taking right now. Is that clear? Is that clear? That are the different forms you need to remember better. The next one is about your Maxwell's distribution of your velocities. Very important relations. Maxwell's distribution of velocities. The graph is important in this one bit. Okay, so if I'm writing the first one, I hope everyone remembers this one. Velocity of your most probable velocity is equals to under root of your 2 into R into T divided by your molecular mass. Next one is nothing but of your average. Average velocity will be equal to under root of your 8R into T divided by your pi times of your capital. The same way third one, VRMS velocity. RMS velocity is equals to under root of your 3 into RT divided by capital. Very famous of all of them. So VRMS is equals to under root of 3RT. V average is equals to under root of your 8RT by M. And V most probable velocity is equals to under root of your 2RT by your capital M participation. Temperature should be taken in kelvins beta. M is a molecular mass taken in kgs and V is the speed in taken in the meter per second. If I'm writing the relations between them, I hope everyone remembered the relation between them beta. Most probable velocity is lesser than of your V average and V average is lesser than of your VRMS participation for a given mass of a gas provided temperature is remaining constant participation. Okay, now if I'm drawing the graph for this one, this graph is very important for me. Okay, so here I am taking right now N into V and here I am taking capital V. So what is your N into V beta right now here? Number of your molecules, whatever you are taking right now, that are the total number of your molecules which have been present in that one. So the graph will go something like this, slowly rises, then again decreases and it will become like this. So if I'm taking the gas, the most of the velocities have been present in this one. The next is certain amount of velocity is present in this region, then certain amount of velocity here. So if I'm writing the values of this one, so this will be equal to your V most probable velocity. This one is of your V average. This one is nothing but of your VRMS. Clear? So I can say that area under this curve will give me, sometimes he'll be asking this question also. Area under curve. Area under curve gives, can you tell me what it gives? It gives me your total number of molecules. Clear? Very important point. Clear? That is an important graph you need to remember in this one. Is it clear, beta? Is it clear? What is NV here, beta? NV is nothing but number of molecules per unit range of your speed. I'll write here itself. NV is nothing but of your number of your molecules per unit range or length of your speeds. Clear? So this is an important graph you need to remember in this one. Clear, beta? Degrees of freedom, I hope everyone has been known. Yesterday only I told you what are the degrees of freedom for the monoatomic, diatomic and triatomic gases participation. And how do you write the internal energy for 1 mole of your gas, which is having enough degrees of freedom? How do you write, beta? I'll just keep a note here right now for you. Very important. Okay. If I'm talking about for 1 mole of your gas, for 1 mole of gas, okay, which has F degrees of freedom. So for n moles, I can write here U is equals to F into N into R into T divided by 2. I hope you remember this one. Yesterday only I told you, isn't it? Now, if I'm talking about your number of degrees for gaseous mixture, for mixture of gases, for mixture of your gases, degrees of freedom, F of your mixture will be equal to your N1 F1 plus of your N2 F2 plus so on up to your Nn into your Fn divided by your N1 plus of your N2 plus so on up to your Nn, total number of molecules. Clear? Now, if I'm writing in terms of temperature of your degrees of freedom for the mixture, temperature of your degrees of your freedom, F is your degrees of freedom beta here right now. So in that time I will be writing F1 N1 into your T1 plus of your F2 N2 into T2 plus so on up to your Fn Nn into temperature of your n molecules of the gases divided by your F1 N1 plus of your F2 N2 plus so on up to your Fn into your Nn. So this is an important relation you need to remember. Okay. Next. Very important. Very important. Last year there was a question on this one. What is that one, beta? Mean free path. Mean free path. Mean free path. Represented by letter lambda. Represented by letter lambda. So what is mean free path, beta? The free path traveled by the molecules between any two collisions, and that is given by the formula lambda is equal. So formula is very important. 1 by this one is under root of your 2 into pi into d square into your L. What is d here, beta? Diameter. D is nothing but equal to your diameter of your molecules. Diameter of your molecules. And what is n here? N is nothing but of your number of your molecules. Number of your molecules per unit volume. Per your unit volume. That is n by v. N by v. Note that when you are using PV is equals to NKT or PKT is equals to NV, the lambda can be replaced by your n can be replaced by the small n can be replaced by your the given condition. Okay, let's see here. PV is equals to your n into k into t. So I can write here P by, this can be taken as of your k into t is equals to your n by v. So that will be equal to small n. That means the small n can be represented by right now lambda is equals to 1 by under root of your 2 into pi into your d square into your n. This n value here I'll be writing with this relation right now. N value will be equal to how much, beta? Here I can write as of your p and kt will go up. So this one will be your k into your t. Clear? So this is also one of the important forms we can write the mean free path. These are the two paths we need to remember. Clear, beta? Okay, so mean free path is nothing but of your tau is equals to your distance traveled by your average velocity. Okay, for calculation of your tau, we can take the different conditions part deflation. And how do we calculate the V average, beta? So V average will be equal to under root of your 8 into RT divided by capital. Clear? And V average is directly proportional to what? V average is directly proportional to root of your temperature. Isn't it? Is that clear? So that means if I'm writing the time of your collision, tau is nothing but what here, beta? Time of your collision. Time of your collision. So tau will be equal to your, so that will be equal to your lambda. Lambda value already I got right now. So that value will be equal to your, in terms of your temperature, if I'm writing, that will be equal to your T. So I can write it is proportional to your absolute temperature T divided by your pressure P, because remaining everything will become for me a constant, isn't it? And in terms of V average, if I'm writing, we know the relation V average is directly proportional to root of your T. So therefore I can write here tau will be proportional to your temperature T divided by your P into this will be 1 by your root of your T. I can even write like this. Clear? So be a little bit careful related to the different forms in which we are writing this one. This is very important basically. Clear? So these are the something knowledge which you need to remember for doing the problems of your KTG particulation. Is it clear, beta? Any doubt in this one? Sure. So very important, beta. 99.99% I have covered everything. You just need to revise it n number of your times, keeping your time into consideration. And especially these relations are very important. So be a little bit specific related to these relations. In terms of your V average and V average root T part deflation, and relaxation time is directly proportional to temperature, inversely proportional to pressure, or directly proportional to your T into P by root of your T part deflation. So different conditions we can write the given part deflation. Clear? And this rule is also very important here, beta. This is very important. What is n, beta here? N is number of molecules per your unit volume, and D is your diameter of your molecules part deflation. Any doubt? Any doubt? This one is also important. For 1 mole, you can take n value is equals to 1 beta. For n moles I have written, you can directly make sure that one. And for the mixture of your gases, degree of freedom can be represented by this formula, and this can be practiced or it can be remembered only by practice. N number of times you need to write on your book and practice, then only you can able to recollect in your examination hall. Otherwise, it will be very hard to remember in the final examination hall. While writing, it will be very easy, but while recollecting, it will become a little bit of your problem particulation. And this point is also very important. Area under this curve will give me what? Total number of your molecules. And what is this n? N is nothing but number of molecules per your unit range. These all things you need to remember, beta, and practice it. That will help you out in a great way for your exam. Is that clear? Is that clear? And tomorrow randomly we'll try to do the questions on your KTG and as well as of your thermodynamics. and come revised even with your thermal properties of matter. We'll also start doing the problems related to that topic also. Okay, now? Is it clear, beta? Sure. I'm ending this session. Take care. Bye.